You know, in the world of flour milling, there are some processes we just take for granted. Today, we're going to challenge a really fundamental one, sifting. And we're going to explore the very real, and often hidden, costs of getting it wrong. So let me ask you a question. For generations, the industry is pretty much run on a simple principle, right? More sieving means purer flour. But what if that core assumption is just wrong? What if it's actually costing you, both in quality and in your overall efficiency? Well, let's take a look at the science that really flips this idea on its head.
We like to call this the quality paradox. And it's that critical point where your efforts to improve the product, in this case, more and more aggressive sieving, actually start to backfire. You hit a point of diminishing returns, and then, believe it or not, the quality of your flour actually starts to go down.
And this really lays out the conflict perfectly. On one side, you've got that common industry belief, more sieving is always better. But on the other, you have the scientific reality. If you push it too far, you end up with quality degradation and real production loss. See, the goal isn't maximum sieving, it's optimal sieving.
So, here's the crucial point. When we over-sift, we're not just getting rid of impurities. We actually start stripping out these essential, high-value components of the endosperm itself. And when that happens, we're fundamentally disrupting the flour's natural balance and how it's supposed to perform.
And, of course, these technical problems have very, very real financial consequences. This isn't just about flour science in a lab. We're talking about your bottom line. It affects everything from your yield to the consistency of your final product. So let's break down exactly how that happens.
Okay, first off, excessive sieving directly tanks your extraction rate. You're physically losing valuable fine endosperm particles that should be in your final product. This loss creates an unbalanced flour, which then, you guessed it, negatively affects critical dough properties, things like stability, absorption, and even the final baked volume. Every single one of these is a direct hit to both your quality and your profitability.
But why? Why does this even happen? The answer isn't what you think. It all comes down to a really fascinating physical phenomenon that's happening inside the plant sifter, right down at a microscopic level.
What you're looking at here is a phenomenon called granular segregation. It's pretty interesting. As the sieve vibrates, the larger, less dense bran particles, they rise to the top. But look closer. The smaller, denser, and most valuable endosperm particles are actually filtering out of the mainstream. They're literally being lost. So this means more vibration doesn't equal better separation, it can actually mean more loss.
And the research on this couldn't be clearer. It says, when sifting is increased beyond a certain limit, it has a direct negative effect on the quality and balance of the milling. There is a clear, definable limit. Pushing past that limit doesn't refine your product, it actively damages it. And that right there is the critical takeaway for any production manager who's looking to optimize their line.
Okay, so we've laid out the problem, and we've looked at the science behind it. The next logical question is, how do we fix it? Well, the solution isn't about guesswork. It's all about precise, intelligent process control.
This really is the key mindset shift you have to make. It's not about just randomly reducing your sieving time or intensity. No, it's about truly understanding and controlling the key variables to get the most efficient separation with the least amount of product loss. It's all about optimization, not just reduction.
So here are the 4 main levers that you can actually control. First up, you've got the sieve opening size. That's your fundamental gatekeeper. Next is the sieve movement, both the type of movement and its intensity. Then, of course, you have the total sieving time. And finally, and this is a big one, the load on the sieve, which is really just the product depth. Mastering how all 4 of these factors play together is the real key to optimizing your output.
At the end of the day, what this all comes down to is expertise. I mean, running a modern mill at peak efficiency demands a deep, scientific understanding of every single stage of the process. And sieving is just a perfect example of a process where more is definitely not better, but smarter is always best.
Now, this explainer was based on the foundational research of engineer Essen Wasef, and his work really challenges all of us to re-examine our processes. So the question I want to leave you with is this: are your current methods truly optimizing for quality, or are they creating hidden costs that you can no longer afford to ignore?